So the bottom line which I am putting on the slide is that you need an extra effort to bind an employees together. You need extra, I would say, more than process and more than English, curriculum which would help everybody on the same page. And believe me, that's where I'm just trying to introduce this Lean Six Sigma from that angle, and that's the angle from where I have learned all these things in General Electric. I'm a green belt, black belt, and master black belt trained in General Electric. So let me ask you this question again. This all Mumbai Dabbawalas tell you that okay, you need an extra effort to bind together, but then why do we need any quality initiative? And of course, there are some of the initiatives which slide number 7 is projecting. Okay, so if I go to slide number 8, okay, now believe that you and me are running a business, everybody. Okay, what are the factors you think are successful for any business to be like successful, or what are the factors which impact the business or which makes the business to be successful? So this is a question on your screen. You can answer. There is a multiple choice you can share. Okay, and I'll wait for few seconds. The the reference also is I am giving on the slide is that the great author Tom Peters, the HR guru, in his book has mentioned this, a passion for excellence. He has mentioned what are the particular factors which can make any organization a successful organization. Okay, so you can write your individual things. Okay, and I'm sure we'll get an answer, but then hold on to your question answers basically. Okay, everybody must have guessed, and now the screen is telling that people think, and everybody says that the top best one is the product quality, and the second topmost which is coming is R&D focus. Okay, let's take only two. Okay, and then of course you can get into world class manufacturing, etc., etc. Of course, you yourself will also must have got really confused about two options which are there in that particular question and answer, but then believe me, what you see on the slide is I need to be proud of my own organization. Mumbai Dabbawalas are proud of their own work. I need not be cursing my organization saying that we don't know how to do these things, how to do this, how to work on this, etc. I need to be proud of what I am doing. Period. Whether it is good, bad, ugly, everything is relative. If I go into somebody else's shoes, definitely things look different. So first is pride in one's organization, and second is enthusiasm. Believe me, everything in the management schools can be taught, but I cannot be taught in these two things saying that oh, start proud, feeling proud about your organization or your work. No, I can't. This comes from your bottom of the heart, has to come from the bottom of the heart. I need to be proud of my organization and of course or my work, and I need to be every day looking at doing something at work, or I need to be enthused about what do I do, and I need to be challenging myself in saying yesterday I did this but I will today do differently. Okay, and this, you can read this book called A Passion for Excellence, and it depicts many things out of on these two topics as well. Okay, so how does really any business typically survives in today's work or work is that everybody says oh no, we hire ordinary people and we get extraordinary work done. Very good. Okay, but how does it happen? And that's where another management guru in his Harvard Business Review publication, Peter Drucker, says, you know, any orchestra, if you look at it, it is not composed of great musicians, but it is composed of people who will produce at their peak, so that everybody at their that particular sort of incidents will be at their peak. And this is how we want in any organization to happen. We want everybody to do something which they did not do yesterday, but everybody need to be producing at their peak basically. And this is where if you need, slide 11 of course tells that you need to have a good process and to work together, otherwise people will not perform. And slide 12 really talks about, shall I wait for my organization to realize this particular thing, or can I be proactive? And this is where it says the proactiveness comes from having the common understanding of a problem or a question, a common methodology, and of course, a cross functional work, etc. And believe me, this is where Lean Six Sigma helps you bind few things together. Okay, so we'll go around. Some of my earlier initial slides are all about explaining the concepts very differently. And now this is where now next of my slides are going to tell you about what is Lean Six Sigma all about. Okay, so I'm not going to give you a definition of XYZ with the Gaussian distribution and integration equation, not at all. I'm going to tell you a simple few stories which basically all of us know also. Okay. Slide 14 I am on. It tells you that if I go in today's world, or I mean, let me recorrect myself, way back in 2000 when the credit cards were taking the shape in India, you apply for a credit card, it will take almost 1.5 months to get a credit card. And this was the process which they used to follow, XYZ. Okay. And 30 to 45 days were the time taken. In today's world, you get credit card maybe less than 7 days, less than a week. What has happened? Does it mean that the organization which issue the credit card have started taking the bigger risk, or do they also have something else to sort of cut down the cycle time? Okay. What many things they have done, they have designed different formats. They started verifying the background on the business card. Address proofs are by using all your PAN cards, voters ID, Aadhaar cards, and nowadays many things. So what has happened is the same credit card companies and the same customers like you and me have started getting things faster. So what has happened is from 30 to 45 days, it has come to a week. And of course, that has swing the business, that has helped each other, all of us also, and economy as well. So this is the one example. Hold on, this example, some of the examples which I still have to cover. Okay. Now I'm on slide 17. This slide 17 title, you will be surprised to see it is something different. All these things are from some of the books and the papers. Okay. This is a story about way back in 1990 in United States, the crime rates were high. So what happens? The government appointed a committee under a gentleman called Alan Fox, and he reported in his report that the rate would be doubled. Okay, so naturally one gets worried. But if you look at the next bullet point, that in year 2000, the crime rate almost came down by half. Okay, so 1990 was high, 95 double, and 2000 came down. And of course, experts were saying something different. So one more committee looked into the aspects. How did it happen? Why did it happen? Or how can it happen? And of course, the reason identified were okay, the economy shaped up, the human initiatives have been helpful to the community, can control, and blah, blah, blah. This is all about the observations from a book, basically, of course. But then the author says none of these were true. None of these observations were true. Naturally, when I say not true, then somebody will ask me, okay, what is the truth? So the individuals say that one factor contributed to all these things. Now, what is that factor? This lady's name, okay, Norma McCorvey, and she had two kids. 1970, she was pregnant, and what did she do? That time in United States also the abortion was illegal, so she filed a case in the Supreme Court. Okay, and in 73, the abortion became legal into United States. What is that has to do with all this crime rate, etc., what I'm talking about? The author says that many of these crimes are done by the kids which sort of were are born into adverse families, and it may almost take 20 years for a kid to get into the wrongdoings. And that's where If you see 73 and 20 years, 95, the crime rate came down extensively, basically. Okay. So this is the factor, the way the author has looked. This is from a book called Freakonomics. Okay. This particular story tells you that you need to really look into differently from the same particular, for the same particular questions. Okay. Now, one more story which I want to take you through. Okay. Yes. Again, all about United States. Two cities, Denver, Washington, D.C. What is same in this? They have same population. Okay. Not bad. The book says that Washington has three times many police than Denver. Fine, we understand it's a capital of the country and hence you have more police force. But then bullet point on slide 19 says that it has eight times murders more than the other city. Naturally, human brain starts thinking, what is this has to do with the more police or the more crime or whatnot? Okay, so I'm saying that unless you have more information, let us not conclude that more police they are ineffective and hence more murder or vice versa and so on and so forth. Let's not comment on that. But the takeaway here is that there is no correlation here. Your mind may want to establish a correlation just based on few facts, but help let's not do that. It does not tell you about any direction or any correlation, this particular story. Okay, let me move on to one more sort of case as a story again from the book called Freakonomics. This is all about a daycare center, and this daycare center location is Israel. Okay, and when you say daycare center creche, there is a opening time and there is a closure time. The closure time this creche has was 4 o'clock, and at times some parents will become late. So what happens is that the teacher can't go home unless the last kid is been picked up by the parents. So somebody did a study on this, and what did they found? They did study for sort of 10 daycare centers for 20 weeks. What was their observation for 4 weeks is that on an average, 8 parents are coming late. Observation is, I'm sorry, got held up, traffic, office issues, blah, 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 or vehicle damage, on many things. Okay. So what to do? Because see, imagine one kid, parents don't show up, the teacher got to wait. So it means your late going is affecting many of the daycare center processes. Okay. So they went to a pair of economists, statisticians, and what did they tell? What did they suggest? They suggested find the parents. Easiest things, maybe, but then they found that this is the best thing to do. Now, let's look at slide 21. What do you note? In the fifth week, they started $3 a fine as a per day late pickup. What happened? Surprisingly, the late picks up went up. What were you expecting? That since I am charging somebody as a tardy parent, the picks up should late pickup should go down. But believe me, it went up. Why? Very clear that parents were saying, I am ready to pay the fine. You better wait for my kid till I come, whether I come late or on time. So the late picks up went up. So on 17th week, what did they do? They stopped the fine. They said, okay, we will not charge you anything. But then the late picks up did not change. Now, why? Human psychology. I am ready to pay. You don't want to charge me, your problem, but I'll come late only. Or I'm not worried about sticking to time. So, what did they do? They increased the fine to $100 from $3. Okay. The story continues, but then we are sort of cutting it here just for learnings of this particular story. You converted one problem to the another problem without understanding it. And what happened? It led to another problem. Okay. Now let me go to another slide, which is 22. And here later I will ask you a question. Okay. Now I'm telling you that I'm buying some products equal quantity and there are two suppliers where there is a cost is same and their quality is also same. So there are supplier 1 and supplier 2. These are the number of days. So I am buying like say 50 products. Supplier 1 takes 12 days. Supplier takes took 27 days probably. This is historical data. Second time I purchased some 70 products. Supplier 2 one was 24 days. Supplier 2 delivered in 7 days. So my question to you, which you will see on the screen, is that which is a good supplier? You need to put your vote on either supplier 1 or either supplier 2. And then I'll take you through the analysis paralysis is which is a good supplier. Okay. Supplier 1 and supplier 2. Supplier, these are the number of days which you can see on my screen. Same quality, same cost, same quantity. Which is the good supplier? Okay. Let me, till we get the voting going on, people said supplier 2 is a good supplier, 62%. Awesome. Very nice participants, which I might say, which I have got because you are helping me really take it to the next topic. And let me just disprove the hypothesis, which is a good supplier, which you all are saying supplier 2. Okay, what I'm trying to do here is just see, I'm just trying to plot the histogram of supplier 1 and supplier 2. And now you see, I'm just trying to put a curve out of supplier 1. Supplier 1, what do you see? 15.8 average or mean. Supplier 2 has got lesser average, which 62% people say is a good supplier because the average, what you see on the screen, 11.2 is the less. But believe me, team, you have forgotten the base. The base of supplier 2, which is a blue base, is very big compared to supplier 1. Okay. So what are we trying to tell you here? Look at the left side screen. Average of supplier 1 is 15.8 days, 2 is 11.2. Yes. So from that aspect, supplier 2 is a good supplier. But then look at this. There is another word which all of us have learned in all our 8, 9, 10 standard maybe or 11th is that standard deviation. What is the standard deviation? How much you are away from the mean. Okay. So supplier 2 standard deviation is 9. You mean so the customer feels variance, not just the mean. So I want to a supplier to be a consistent. I want everybody to perform consistently, not that you get one time 0 mark and one time 100 marks. No, you need to be consistent player. Okay. And this is what all about variance and not just the mean. Okay. So I'm moving to slide number 23. Okay. And you will see on your screen a question. So from this story of a daycare center, police and the crime, and abortion to economy, and the supplier. What are your takeaways? Okay, so you can choose to answer on slide 23. What are the your learnings from these four stories? You can have multiple choice. Okay, should I look at answers in the data, or shall I make an assumption and then prove it right wrong? Shall I drill down for the root causes or drill down and data can highlight the surprising results, or does data is sufficient to arrive on the root causes? Let's wait for folks to really look at this particular
Okay.
answers.
Sir, for this question, multiple answers can be selected.
Yes, multiple answers can be selected. When there is a radio button, only one you can select. But then when you are in checkbox, then you can select multiple. Okay, so will we what we see is this. Okay, the best The biggest thing what has come out is that drill down and data can highlight surprising results. Yes, definitely. Drill down for the root causes. Of course, yes. Yeah, okay, you can also say that the last one what you got is look for data answers in the data has got minimum percentage, because yes, the the data can highlight and the drill down is together. So maybe folks choose not to answer that particular thing as important thing. But see, there are takeaways here. Indeed, I'm just sparking you is that if you have seen this radio button or the questions where you have answered multiple choices, if you understood that, then that is all about Lean Six Sigma. Yes. Thank you, Professor Bishwas. This, what you see on this screen, is all about Lean Six Sigma. And let me refresh you again with all those takeaways before plunging into the data. Ask questions to drill down to the root cause of analysis. Seek out the answers in the data. Yes, we need to look at the answers only into the data. Okay. Another last bullet point is good to opine or theorize about a subject. Okay, which replaces the moral by the honest assessment of the data. So I'm telling you the why the data results are surprising. Oh, the first story of abortion to economy. Why what surprising? What it was for that, because the way they drilled down, they looked at the data was totally a different outcome basically. Okay, and that's where now, if you understood these four of the five stories, believe me, that's the basis of Lean Six Sigma. Statistics, yes, statistics is there to help you out to fetch the analysis out of the data. But then believe me, who collects the data? We collect the data. How do we collect the data? It is our choice. So this data collection, data drill down is a double-edged sword. You can use to really prove and disprove the things as well. So let's understand these things. How do we really go? Now, what is Six Sigma? Okay, so we understood what is Lean Six Sigma. Now I'm just trying to bifurcate Lean and Six Sigma here for the technical things, basically. Okay, so what is Six Sigma here? I'm just trying to get into a manufacturing aspect just to explain this concept now. Okay, so what do you see on slide 24 is it's a measure of quality. It's a process for continuous improvement. And believe me, it helps an organization to enable any cultural change. Believe me, otherwise people get many things personally, they take personal things personally, and of course then it leads to a different outcome basically. Okay, so you see three bullet points, but believe me, there are 6 points in that. There has to be a measure and what of quality. It's all about a process, but it's a continuous improvement, and it is an enabler. What does it enable? Lean Six Sigma enables a cultural change. Anything which is new, which doesn't get digested easily. Okay, that's all about Lean Six Sigma. So look at the first thing. What is it all about? Measure of quality. What is quality? It's a statistical program. Okay. Now let me highlight one thing that okay, there may be many statisticians in this participant, but believe me, the statistics and data has to help us. We should not get carried away by the statistics or the data. Otherwise, only Six Sigma would have been a statistician's tool. But believe me, I'm an engineer and practice Lean Six Sigma, and I say that it should be a part of the DNA of any business, basically. Okay, so let's understand what is Lean Six Sigma, Six Sigma here, and how do I measure Six Sigma as a capability. So I'm taking a manufacturing as a example here. Let's say that we are working in a company which makes the sheet. Okay, what you see in the screen is a sheet metal thickness company. I'm introducing a word called CTQ, which is mean that critical to quality. That okay, if my customer wants to buy this sheet from me, what is that one parameter on which he wants to buy this particular thing? Okay, so he says that I want a sheet thickness to be a critical parameter, and he says 1,000 units around the coil is my expectations. Okay, but then always, so on I'm slide 27, he says 1,000 micrometers is my expectation. But then believe me, Can you produce exact 1,000 every ship and every month, every day? No, not possible. Always there is going to be variation. Like go back to the supplier example where I say supplier one, supplier two, everything is same, but they took different number of days. Okay. So we are talking about variation now or standard deviation. So I ask my customer, 1,000 exact, not possible. Help me get a range. So customer says, okay, you take lower sum limit and upper sum limit. There may be processes where customer may give you only one limit, saying that okay, you need to be either on lower side or on the upper side. So I'm a manufacturing company. I start producing. Okay, my manufacturing starts, and every day, what do you see on the screen? That white bullet, white dot is the average sheet thickness, which is produced in a day or in a ship or in a month, whatever. Okay, this is just an example. Okay, so every day I produce, and this is how the average sheet thickness at times goes out of the limit, within the limit, etc. And then I have just tried putting a curve or a distribution around it. Okay, what do you see here? Customer wanted 1,000. He allowed me 950 and 1050 as grace marks, but then still on the screen you see there are many things beyond 1050 and there are many things below 950. So customer will definitely not accept those things, and believe me, that's a waste of my efforts, energy, cost, material, and manpower, and that is scrap. And that is what customer will not pay for. So if you have more scrap, then naturally your cost of the product will be more. Okay, so how do we really minimize the scrap is the theme, and that's the manufacturing thing. And this is where now I'm trying to introduce how do you measure a sigma capability of a process. Let us keep one thing in mind. Sigma means standard deviation. Okay, and 6 means 6 standard deviation can be fitted on one side of the curve. What you see on the screen is a green line, which is the mean or the target, and one side is on the left side or on the right side, whatever side you need to have, how many standard deviation can be fitted. Okay, so if your process same, I'm taking the same sheet metal thickness example where the specification was 950 1050, so difference is 100. So if my spec width is 100 and my standard deviation become 25, which means sigma level is 2, I will have 3 lakh 8,500 defects in million opportunities. What is DPMO called? Defects per million opportunities. So what does it mean? I have 70% almost area under the curve, okay, which is okay. So 30% is the waste or the defects. Now look at the screen. I'm going to the next process, next level, 3 sigma. If my process I improve on and it becomes 3 sigma, what happens? My standard deviation has gone down. See, my spec width will remain always same, 950, 1050. Those are the specifications given by the customer. So what happens is in a million opportunities, I have come down drastically to 66,000. Okay. So my 93% area under the curve becomes better. Look at the screen. In a 4 sigma, it becomes far better. 6,200 defects. Come to 5 sigma, just it is going to 3 digits. Naturally, a better output, very less defects, and the area under the curve 99.98 is the good thing, because you see, look at the screen now, it has totally come inside the lower spec and upper spec given by the customer. Okay, now I'm coming to a sigma called 6 sigma. There are 3.4, okay, 3.4 defects in a million opportunities, and my process is 6 sigma. You may ask me a question, can there be a sigma where there will be 0 defects? Frankly speaking, let me highlight this fact that the red curve what you see on the screen is nothing but a curve called normal or a Gaussian distribution. This distribution operates between minus infinity to plus infinity, and believe me, this curve will never cross x-axis. It will go asymptotic, means it will always run parallel to the x-axis, but it will never cross x-axis. And since it will not cross the axis, you will have no defects. You will have no sigma level where there will be zero defects. It can become 0.001, but it will never become zero. Let us not try to be expert in the beginning of what is zero defect and this and that. Let us understand the concept here. Okay, so sigma is a capability how you measure the process. Okay, so now I am on trying to take you through some transactional processes. Okay, where if there is a courier company and they say that they are 99% good process, they may have 20,000 mail lost articles in an hour. Okay, and they become good where they say 7 lost per hour. Okay, and still they claim 99.99% to be better. Then if I have a drinking water company, these many defects allowed. Hospital surgery, look at that. Or if I am having a travel company, air travel. If you look at these two as an example, which I am trying to tell you is that percentage what you see on the screen, that somebody is 99% good, still have that red color defects, and somebody has improved to 99.997 as a good, okay, but still has some defects. Now in percentage, 99 or any percentage is not good because your population on which you are evaluating doesn't get highlighted basically. Okay, so you will see on the screen a question now. Okay, does the percentage measurement what you and me use in day-to-day life covers or conveys the real story? If you say yes, you'll have to click on yes. If no, then no. But why, etc., we'll just discuss once all of you answer this particular question. Okay, so let's look at where how many says percentage covers and how many things. Believe me, still, if you read these two things together, okay, on the same screen, I'm just trying to slide. Okay, 45% people are saying percentage is still a better measurement. Let me highlight that it is not percentage in this particular red color graph which I'm trying to show on the screen. Still, they are 99% good. But can you, would you be able to work in a company where there are 20,000 courier envelopes are getting lost in an hour? And that is the 3.8 sigma capability. If you move to 6 sigma capability, believe me, you have only 7 lost. Okay, but then from defects from 99 you have just come down, you have increased to 99.997. So percentage depict measurement is basically a misnomer. It's not going to give you an appropriate measurement because you are measuring the height of a person or height of many people and everybody is standing on a different platform. That is not going to tell you that who is taller than whom. If you want everything to be measured on a one platform, you need to bring everybody on one platform. And that is what this Six Sigma process does. What does it do? It brings everything on that defects per million opportunity platform, basically. So everything is measured with respect to million opportunity, nothing less, nothing more. Okay. So sigma basically is the standard deviation, and how many standard deviation you can fit on one side of the distribution is the capability measurement. And it doesn't talk about or percentage, but the percentage is a misnomer is what I tried highlighting through this some of these examples. Okay, so this is how you can look at Six Sigma capability, what I introduced, defects per million, or you can say parts per million, one and the same. So as you had 2 sigma, you had 3 lakh defects in 10 lakhs as 1 million. And as you come down, your defects really come down. So sigma capability really helps you measure the defects at one platform. Okay, it is not in terms of percentages. Okay, so let me go to the next slide. Okay, So what is, if you look at the two curves which I'm showing on the screen, one process which is on the left side, it is off the target. One is everything is meeting the target, but then there are defects which are the brown color ones. Okay. So I have a question for you on the screen. How should be an ideal process? It should just be at the center. It should reduce the variation, or ideally you want both of the above. If you look at this, this is the right side is the centering, the left one is reducing the variation. Okay, but then what is that you would really like to have a process to be? And let's look at the answers. People said, I want to reduce the variation. Okay, so interesting outcome. If you want to reduce the variation, then look at the left side screen. So you have less variation. But is it around the target? No. On the right, people said center the process. Okay, 35% centering the process. But then you still have defects. So ideally, what I'm trying to show you is this, that you should center the process and you should reduce the speed also. You should reduce the spread also. Okay, and this is where you want to have a sleek process where the mean or the target of the process is at the center, and you will have equal spread on both sides on the LSL as the lower spec limit and the upper spec limit basically. Okay, so this is how I was just trying to explain you how many standard deviation you can fit on one side of the curve. You are able to fit 6 standard deviation on one side of the curve, and this is how you will have 6 standard deviation on one side, which is a Six Sigma process. It is not on both sides, it is one side from target or the mean basically. Okay, so now let's get into the second top of the Six Sigma called process for continuous improvement. Okay, I am on slide 40. So there are systematic approaches of taking this methodology forward. So the one first approach is called DMAIC. Okay, so you define the problem, you find out what is the measurable in the problem, you analyze the existing problem, then get into smallest improvement, biggest improvement, etc., and then sustain the improvements, which is controlling. Okay, so it is DMAIC. Most of the businesses in day-to-day operation use DMAIC as a methodology. Okay, so here you want to have the process to be a tighter process. Okay, now on the screen what you can see is basically a process, basically a picture where there is an accident. It's an accident story, Indian accident. Let me rephrase my sentence. It's an Indian accident story. A center light and a car is banged by the truck on the backside. You can see that the car was changing the lane. The truck is center of the road on the lane, and imagine that you and me, all of us are traveling in the bus. Okay, as the bus comes around near the accident spot, and imagine all of us get down. Okay, what questions would come in your mind? What you see on your slide is this. If you can think of these questions, what questions would come in your mind? What happened? Did anybody get hurt? How did it happen? Should I have done this way, or personally I shall do this way? You can have all choices, you can have few choices, etc., but what questions will come in your mind is my question to you. Imagine the accident story where there is no clarity, but then all of us are traveling in a bus and we come nearby the accident venue. What comes in our mind? Okay, I'm glad to see that most of you said, how did it happen? Okay, and this is where, believe me, all of us mentally, psychologically start jumping on it. You will see that there is equal scatter. I might say that on an average, what happened also has got 55%. Anybody get hurt psychologically 60%. But let me just explain that particular methodology. Okay, as we all get down. Okay, now what you see on the screen is question one. I'm just trying to tell this in Hindi. Kya hua? Believe me. Who can answer this? Kya hua? We are asking to each other. The person who met with accident, both this truck driver and maybe this car or taxi driver, can only answer. But no, we go on. क्या हुआ? Second, कुछ लगा तो नहीं. So we get into something as a measurement. Okay, analysis. कैसे हुआ? Lane crossing, did not look into back, signal was red, blah blah blah. Question 4. Now you started giving an advice. ऐसे करना चाहिए था, etc. etc. And a conclusion for yourself. अगले time से I will not, I will look into back, I will look into screen, I look back, I'll wait for the signal, etc. And believe me, if you all understand all these things, then this is DMIC method. All of us have all these phases in our mind. So you answered appropriately for the question. But if you follow this particular sequence, then you understand what is Six Sigma, or you understand what is Lean Six Sigma all about. How do we really take these steps in solving the problem? So this DMAIC is nothing but an approach to not only solve the problem, but to understand the problem also. And what is the difference between problem and question? Many times people say that I know the solution, but I don't know how to get it. And that's where problem and question has two different severities to it. But then DMIC can be used as a method to understand or to address both, basically. Then there is another method called DMA and DV. Okay. This methodology is typically used for research and development purposes where nothing is known, but you want to design something. Okay. So if you go back to Graham Bell days, what was the telephone invention all about? The voice modulation into electrical modulation and back to voice modulation. Okay. So that was the concept. When it came to mobile, then you say that, okay, that voice modulation without signal or without electrical connectivity, it gets into another voice modulation. So that's how the DMA DV can be derived, okay, into a different particular, into a problem which is unknown, basically, okay. Example which I want to just share with you from my existing business, which we have, is we have developed and we have patented also one heat treatment process. How did we do? We started with the same, define the problem. We wanted to have a product which needs to have a case hardening. Then how do you measure? You want to do it in a special furnace or a regular furnace, and a corrosion resistance is a measurement. How do you analyze? We analyze various steels. How do we really do it, etc. How did we design the product or the process? We got into some furnace design, but we said we will use the existing furnace because then otherwise cost wise it will not be compatible. Then we came out with a couple of combinations, and believe me, that is where we got a patent of ours. Okay. So if you have DMA DV process for any research and development, typically in the design stage only many patents are shaped or many disclosures are really filed, basically. Okay. And then of course you verify and you have your process taking it to the next level. Okay. So this is the DMA DV example which I just wanted to give you on the R&D purposes. Software or coding or IT things, basically you can have the same DMA DV in terms of initiating the code or read or the logic, requirements measurements, design the logic, design the process, build and the test cases or the logic, and of course deploy means verify. So whether if you go via DMA DV, also you can get into many toll gates and clear the same process for your own software purposes also, or where or your IT or coding or the logic purposes also. Okay. So the third bullet point which I am trying to address now is that what is the enabler for the cultural change? And this is where in a new process is not really accepted, doesn't get digested. Okay. And this is where most of the organizations spend time. And that's the suggestion is that if anybody wants to practice Six Sigma, Lean Six Sigma into an organization, it has to be a top-down approach, because the organization need to have a buy-in of the process, that okay, we want to have something done for the measurement purposes, something needs to be done on one, to be on the one platform, etc. Okay. So Six Sigma is a cultural change, the way you want to have some measurements done. Okay. And this is where I just want to show you this particular thing, that what is before Six Sigma and what are before after Six Sigma or with Six Sigma. A fundamentally a different approach of working on a measurement, working on a process, working on an improvement also. When you say improvement, people really do not look into what can be failure modes, what would be the ideal way of measuring the process. Or if you say that I measure a potato using the weigh balance, I measure the gold also using the weigh balance. The way you measure the gold and the way you measure the potato are two different things. Why? Of course, the pricing and the commodities are different, but then if you have the same gold measured in one way balance as 10 grams, you go anywhere, the measurement comes to be exact 10 grams always. Why? The way balances are calibrated. The way balance, the way they are kept also are calibrated, or it's the best way it has been kept. Whereas if you look at the potato as a commodity, 1 kg here can become something different at different place as well, because the things are different. And this is where a measurement concept called gauge R&R comes in picture, which is called gauge repeatability and reproducibility. One, repeatability is to do with an equipment, and reproducibility is to do with operator. So in DMAIC stage or DMADV, in measure phase, you need to worry about that gauge R&R for sure. And this is what I want to show you, that as a enabler, as a cultural change, this is where you need to really have calibration of your workman as operator and your gauge as your way balance as well. Okay. So this is how the cultural change needs to be driven. Otherwise, fundamentally, Six Sigma in many organizations have failed also. They are unable, they were not able to take it forward. Okay. So in the community, in Six Sigma community, if you see, all these are driven as a certifications. Many of you may have some questions in mind. How do I really get certified, etc.? Yes, there are private consultancies, agencies, universities which give you green, black, master, black belt as a certification. Most of these agencies or consultancies, they drive technicality as a statistics things, and they take many exams, etc. But all these organizations which have implemented, like General Electric did in way back in 1995 2000, Motorola started with, IBM did it. Now many business process outsourcing, BPO unit does, or many IT companies are doing. The typical measurement is this is how they have done. Green belt is a training of few days and a project, and of course there is an exam. Then black belt means you have to mentor some of the projects, and you need to yourself do some project. So one who can work independently, one who can guide green belts, and who is seen or perceived as a change agent from the personality perspective also. Okay. And a master black belt means one who owns, drives, and of course mentors the black belts. This is how typically master black belt and green and all those are defined across. There are severities of the exams also. Okay. Green belt, yes, passing 65%, black belt each percentage, each section 65%, and master black belt more than 65%. Okay. We are not going to discuss the criteria here, but these are the criteria which most of the organizations are following up for Six Sigma implementation as well. Okay, people talk about investment, what is required. No, it's a cultural change. See, there are two words. You may have a fundamental question in mind: what is lean and what is Six Sigma? The credit card example what I gave you was all about lean, where you have cut down the cycle time, you have reduced the waste, you have eliminated the waste or the cycle which was not required. Then Six Sigma, what I qualified is in a million opportunities, what is your product measurement? How many are the bad product? When you say Six Sigma, we said in 1 million there will be 3.4 defects. Okay, so Six Sigma is all about defects measurement, defect reduction. Lean is all about reducing the waste. So when you say I have a process, I want to improve the speed of the process, lean, value stream mapping, etc. helps you. But then if you have more defects and the speed of the process is increased, the defects produced will be again a more. Okay, so you are wasting your efforts also. So in conjunction, when you use lean and Six Sigma together, first of all you need to look at how do I control defects, how do I measure my defects, and then how do I increase the speed of the process. Otherwise you will increase the speed, but then the defects will also substantially or exponentially increase, basically. Okay, so look at the concept of lean Six Sigma as a together one. Okay, and how can one really get started? Basically is what it is all about. Get everybody involved. It is not a function which can be done. Of course, theory learning you can do alone, but implementation has to be cross-functional team. There need to be people working together. Okay, and they need to discuss, rediscuss, and improve on, and challenge yourself, basically. Okay, so I have a question here on the slide. So does a Lean Six Sigma need to be driven or roll out as a statistical approach, or just a tool or initiative or a method of improving, understanding, solving a question or a problem? So what do you think all about after going through the 50 slides? Okay, I just wanted to understand, where do you see yourself as a Lean Six Sigma awareness now? Okay, do you think it's a statistical tool, or do you think it's a methodology of taking a systematic approach of even understanding or solving a problem? Okay, so let's wait for everybody to answer. And yes, believe me, that 80% and 20%, I wasn't expecting 100% people to say that it's a methodology of the tool. No, there is a statistics into it, but the major portion of it, 80%, which you have rightly answered, is it is needs to be a methodology of understanding, solving, and something working together. If all of you have understood this particular thing, and if you remember all those four stories which I have explained in the beginning, believe me, the purpose of this particular introduction webinar is solved. Of course, I do have few slides, and I have kept 10 minutes for any question and answers or any feedback, etc., so that we can really look it forward also. Okay, let me move on to my next slide. Okay, so typically, how is this improvement really getting addressed? People talk about efficiency and effectiveness, and imagine what we have seen as a methodology. It does help you address both doing the right things, but doing things right. Okay, and this is where, whether you have volume of rework or whether you have measurement of cycle time, services, accuracy, etc., you can use this Lean Six Sigma methodology to take these things across. Okay, so on a nutshell, if I have to summarize, how do I really look at a business problem? Okay, do I really look at symptoms, then there are baseline performance, then I get into solution and sustenance? Yes, then you can look into various approaches. You want to have lean focus, simple, don't get into too many details, just do something called value stream mapping, and in a month or two things can be improved, and of course the improvement results can be discretized. Okay, but then if you want to look into Six Sigma focus as such, what you can see on the screen, basically. Okay, then in that case, yes, Then there are two approaches, which I said DMA-DV and DMA-IC. The first one, improve existing one, is the DMA-IC approach. It's a data driven, okay, but it need not be that big. It can be taken in a 6 months, 3 months time as an improvement. And a DMA-DV, yes, it takes a good amount of time because it is all about looking into which is unknown. Basically, it is unknown because it is a new thing which you want to address as such. Okay, so DMA-DV, or people call it DFSS also. It is called Design for Six Sigma. Okay, so if I show this particular screen, what does it tell you? A crowded slide, maybe. Okay, number of years, maybe few companies spend in improving Lean Six Sigma or implementing Lean Six Sigma, and as a process capability on the y-axis. Okay, easy as is one. If you measure, most of the organizations, they really say that we are in 1 year we are 2 sigma company, which is always easy. And if you go around 3 sigma and say that we are good, we started knowing what it is all about, etc., yes, it may take, in today's world, of course these timings are relative timings, but then 1 to 1.5 year you can get that. But if you want to go where this is all 4.5, 5 sigma or 6 sigma, then you got to get into many new things, which is automation. You need to get into some of the Six Sigma tools. And of course, the statistics also need to be used in the background. Basically, it is not that without statistics you can run Six Sigma. No, not at all. Okay, but yes, it need not be only statistical driven, but it can be really used as that particular cultural change things, and then the process improvement can be measured. Okay, so I have a question for you on slide here. So can the Lean Six Sigma be applicable to any areas? What we have really seen some of the examples on just a bird's eye view. Okay, what do you think? In fact, it's a methodology. So what I measure is up to an organization or up to me. So I do not see any tooling limitations of Lean Six Sigma, not where it cannot be used, etc. But then just towards the end of this slide, we have just 2 slides left, and just wanted to understand where all of us are on the same page. Very nice, very nice. I'm really happy to see this. And of course, Professor Sarvodaya and Professor Bishwas had that particular thing, that yes, we want to just spark people with this tool as a thought process, that it can be used for any of this business field. Okay, how do we really look at it is up to us. Okay, guys. Now I'm slide number 55. Just want to park with you with saying that do not make common mistakes. Okay, of course, one need not make mistake itself, but then do not make the common mistakes because, oh, I will do myself all these things. No, there are many experts, there are many mentors, there are many Google literatures available. You can get into and then start learning from it. Do not reinvent the wheel. In fact, I have said that steal with pride and integrity from everywhere. That is called swipe. Why? Because if research has been done, why do I really waste my time in all those things? Okay, there are many tools which are available into the open literature also, so one can really use those tools, those learnings. Yes, you can get in touch with us also, and we will help you really understand or really not do those things as well. Of course, still my learnings and must do's continues. That was don'ts, and this is do's. If you want to do this as an approach, as a learning, as an implementation, okay, you need to have a goal clear. It is not that in one night the Lean Six Sigma implementation is done and we are good at it. No. Integrate Lean with Six Sigma as a methodology together. You need to have, if not a big team of mentors, you need to have at least few people who understand these concepts from couple of angles. Okay. And let us not say that we have too many initiatives going around. Okay, but then yes, use this particular methodology to drive the improvement or the measurement as a common platform across, basically. Okay, and of course what is measured is only done, and that's why all these improvements needs to be really carried on by or verified by the finance as a team. Okay, not that You have PowerPoint as a big saving, but the power of the point is not there. So let's not only do the PowerPoint measurement. Okay. So what I want to really park you with the thanking note saying that let's not think too much basically, but let's get into something which you can really start implementing and start measuring and start really calibrating yourself as a immediate thing, rather than working. I'm planning the work and executing the plan, so we need to execute the plan. Let's not have only the planning the work. Okay. So with this particular thing, I really thank Dr. Bishwas and Dr. Dilip Sarode for giving me this wonderful opportunity. I started at least tried commenting and convincing on the thought process, etc. And of course, you have any questions, etc. We have still 5 minutes left for the session to go on. But otherwise, also I have shared my LinkedIn address, etc. You can get in touch with me via ICT as well, and will be very glad to be associated with you in terms of taking this learning to at least implementation or your particular organizational benefits. Thank you so much. I appreciate. Thank you.
Thank you, Dr. Kansan Chaudhary, for your
Yes,
enlightening
Sarvades.
speech
Yes,
on
Sarvades.
very difficult topic. Actually, it's very difficult. I know, I recall the days when I studied in VJTI. Those days, there were no electronics and computer branches, but only production was the topmost branch where all these concepts were taught. And we are fortunate that in our department, we have two faculty members who have studied way back in late 80s these concepts. And we are progressing a lot in our department. I'm extremely thankful for sparing your valuable time and highlighting the today's webinar attendees, the importance in each and every field, not only in the manufacturing, but in services, in IT sector also. And it's a work of a team, not a single person's job, but it's a teamwork. Okay? So that is the takeaway what I could see from today's lecture. So I am extremely thankful for sparing your time and giving your valuable experience findings on this concept, and definitely it will be very useful in the long run. At the same time, I must thank our Dr. Deepankar Biswas for ably handling this session and coordinating with you for last couple of days and formulating the question answers, and so that you can see how the audience is also thinking after hearing your lecture.
Thank you, sir. Thank you very much.
It is
I
very
enjoyed
important.
as well.
And the most satisfying part is at the end, we got 100%.
Thank you.
So that means everybody, participants were attentive. That is very important. They were attentive and they were understanding what you are saying, and very useful. Let us hope that they will implement this in your day-to-day life and in their professional life, and try to improve the efficiency and effectiveness of their time and all the resources with which they are blessed with from the God, and learn all the way of their engineering profession. And I must thank the ICT authorities as well as the Technical Education Quality Improvement Program and our associated organizations, that is BIT Meshra and Government College of Engineering Keonzhar, for involving in this, organizing this webinar. And let us look forward. Let me tell you, our Department of General Engineering is a department in Institute of Chemical Technology. Besides teaching the common subjects of fundamental nature, that is mechanics, electrical, electronics, and uh, engineering graphics, we are running master degree program in plastic engineering. And I think it's one of the oldest program, master degree program, started way back in 1972. And last 10 years, we are also offering PhD program in mechanical, electricals, electronics, civil engineering, and plastic engineering. And I'm happy to mention here that we have presently we have more than 50 PhD scholars, and we have also some scholars from the industry, PSF and Tata Motors and all. And I'm sure all our students are also got benefited because of your lecture. We look forward for your continuous support to our department and ICT in long run. Thank you, sir.
Thank you very much, sir. I really enjoyed, and I would park that every researcher who will work on any project, I think Lean Six Sigma, if it is a part of the tooling, it will really help an individual save time and come out with a research more prominently. So
Thank you.
thank you so much. I
Thank you,
really
sir.
enjoyed. Thank you.
Thank you, sir.
Appreciate.
Thank
Thank you.